Hello students and parents. So today we are going to discuss about resolution of vectors. Please see the earlier videos on basic of vectors wherein we have seen what are the two physical quantities which we are going to cover in physics, that is the scalar and the vector quantities, and what are the properties, what are the features of scalar and vector we have covered in the previous video. So in this particular session we are going to see a resolution of vectors. Okay, we are going to see resolution of vectors for two-dimensional and three-dimensional. Okay, so let us start. I'll clear this. So far what we have seen is we have a vector A and vector B, then the resultant is given by vector C, right? So A plus B vector is equal to C vector. This we can also write as C vector is equal to A vector plus B vector. We can also write it like this, right? So now if we take this vector system in a coordinate system, let's see how to resolve. Let's see how to resolve it into the components along x and y axis. This is for two-dimensional. Okay, let us clear this. So we have the coordinate system. Let us say we have one vector this way and another vector going at the right angle displacement upward. This is ax vector and this is ay vector. So the resultant is a vector. Okay? This is x axis, this is y axis. So a can be denoted as, in the coordinate system we can write a as equal to ax vector plus ay vector. So far so good. Now let us say we have two vectors. I'll clear this. Now let us say we have two vectors A and then another vector going this way, B vector. So this component along the x-axis will be called as AX and this component along the y-axis will be called as AY. Now for B vector, this component will be BX and this component will be BY. So we can say that this resultant vector is C. So C also will have two components, right? One along x and one along y. So C component of x vector, C component along x axis is equal to A along x plus B along x. Then Cy can be denoted as A along y plus B along y. So now we can simply write C vector is equal to Cx plus Cy vector, right? So now what we can see overall. So by studying this, we now see that, I'll take to the next slide. We now see that vector A can be specified can be specified. I'll draw the diagram first. It can be specified in the coordinate system as a vector with an angle theta, right? So it is, this vector is specified by its magnitude a and angle theta with x-axis. This is how it is specified. What does it mean? It's called as the magnitude angle rotation. That means basically this vector a has changed its direction. It has moved from here to here at an angle theta. That is, so this vector a is making an angle theta with the x-axis. Or another way is, we have this vector a, we have this vector a. We can take the component of a along x. This component will be denoted as ax. Let us denote it as ax. And the component of a along y will be called as ay. This is the other way of representing the same vector a. So what we will have now? This component, we know that this is making an angle theta. So this component ax, the vector ax, can be written as a, this is the adjacent side to theta. So it will be written as a cos theta I cap, because it's along x-axis. And along y-axis, ay can be written as ay is equal to, now this is the sine component, right? It will be a sine theta j cap. So ax is equal to a cos of theta, and ay is equal to a sine of theta. So hence a is equal to square root of ax square, because it's a right angle, ax square plus ay square. And theta can be written as tan inverse of opposite by adjacent, and opposite is ay by ax. This you are supposed to resolve vectors for two-dimensional. This is two-dimensional resolution in a coordinate system. Now we'll see three-dimensional resolution. We'll clear this out. I'll clear this out. Three-dimensional. Now we'll have another component called z, right? So we'll have one component y, we'll have x component, and then we'll have z component. So if you have a, let us take a somewhere. It will appear like somewhere here in between. If it's a cube somewhere in between, doesn't appear exactly like somewhere in between. But this is a. If you can imagine it, it will be better. So the component of a along y will be called ay. Along x will be ax, and along z will be called az. So a can be written as az plus ay plus ax vector. So here magnitude of vector will be written as square root of az square plus ay square plus ax square. This is how you are supposed to represent the magnitude. Now each of them will be making some angle. Right? This component will make some angle with y. It will make some angle with z, and it will make some angle with x. Let's say the angle made with z is alpha, then A of Z can be written as, because it is along, right? It will be the adjacent. Angle will be something like this, then something like this, and then this angle also, right? So this, if I denote this as alpha, and with y is beta, and with x it is gamma, then I say A of z is the adjacent component, right? If it is an adjacent component, then it will be written as A cos of alpha, and ay is written as A cos beta, and ax will be written as A cos gamma. This is how you're supposed to resolve. These are called as the, these components here, cos alpha, cos beta, and cos gamma. These are called as direction cosine. Direction cosines of A vector. And direction cosines have a property, and that property I will write it here. I'll write it on next slide better. The property, direction cosine property is cos square alpha plus cos square beta plus cos square gamma is equal to 1. This you're supposed to remember. So let's summarize. I'll clear this. Let's summarize what we have seen in this chapter. We have seen resolution of vectors. Clear this summary. We have seen resolution. If we have in a 2D, if it is a 2D, if we have a vector A, then we can resolve this as this vector along, if it is an angle theta, then along x-axis will be A cos theta, and along y-axis will be A sin theta, right? So A of x will be A cos theta, and A of and the y side will be A sin theta, and the resultant will be given as square root of ax square plus ay square, right? This is for 2D. Then we have seen resolution for 3D as well, where we have vector like this, a y, x, and z, right? So we had a vector A, okay, this is making with z alpha, with y it is making beta, and with x it is making gamma, right? So A along z can be resolved as A cos of alpha. Likewise, for along y and x axis, it is given here. Okay, and as per cosine rule, we see that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So that's all for resolution of vectors. Stay tuned on. We'll solve some problems for resolution. See you until then. Like, subscribe, and share. Bye.